Polymer Surgeon. We are from class RAS1134C.
Let's introduce our member.
My name is Syahirah. My name is Nurul Awatif.
My name is Nur Alia. Today, we want to talk about derivation. For introduction, this assessment consists of 4 questions and will cover about following topic. The first one, technique of derivation, and second, derivation of trigo, exponential and log function. Third, the chain rule. Fourth, implicit derivation, and lastly, linear exponential and differential. What is differentiation? Differentiation is method of finding the derivative of a function. We find the rate of change of the function fx with respect to x at a point lying in its domain. The most common example is the rate change of displacement with respect to time. We call velocity. The opposite of finding a derivative is anti-differentiation. Differentiation is very useful to use when it comes to real-life situation. For instance, it's involved in engineering, economy, medic, or finance. We continue for technique of differentiation. We show that techniques and formula. The first one, basic rule, product rule, quotient rule, chain rule, trigo derivative, and exponent log derivative, implicit differentiation, and last one, log differentiation.
Question 2a. Find dy per dx for the following function. A. 3x squared, second bracket x plus 2. So, as you can see here, we have two functions, which is, the first function is 3x squared and the second function is second bracket x plus 2. Since we have two functions, we need to implement product rules. So, we need to find u, v, u prime and v prime. So, u is 3x squared, v is second bracket x plus 2, and to find u prime, we need to differentiate the 3x squared. So the answer we get 6x. And to find v prime, we can use the basic derivative, which is d per dx bracket second x equal to second x times tan x. So the answer for v prime is second bracket x plus 2 times tan bracket x plus 2. So as we get this 4 information, we can apply it into product rules formula, which is 2v prime plus vu prime. So it will get 3x squared times second bracket x plus 2 times tan bracket x plus 2 plus second bracket x plus 2 times 6x. So the final answer we get 3x squared second bracket x plus 2 times tan bracket x plus 2 plus 6x second bracket x plus 2.
For question 2b, we apply quotient rule. The formula is v u prime subtracts u v prime divided by v square. Make sure use the formula quotient rule. We can write dy over dx is cos x in bracket 4 subtracts 4x plus 2 and in bracket negative sin x divided by cos x squared. For simplify this answer, you can write dy over dx is 4 cos x plus 2 in bracket sin x divided by cos x squared. You get the final.
Question 3. Given y long bracket 3x minus e power of 2x plus 1 minus tan 4y equals to 0. Find dy per dx using implicit differentiation. First step is we need to differentiate all terms. First, we need to differentiate the d per dx bracket y ln bracket 3x. So, as you can see here, we have two functions, which is the first function is y and the second function is ln bracket 3x. So we need to find u, v, u prime and v prime. So u is y, v is ln bracket 3x and u prime is dy per dx and v prime is 1 per x. So as we get this four information, we just apply it into product rules formula, which is u v prime plus v u prime. So it we get y times 1 per x plus ln bracket 3x times dy per dx. So the answer we get y per x plus ln bracket 3x times dy per dx. Next, we need to differentiate the d per dx bracket negative e power of 2x plus 1. So we need to use the chain rules and the answer we get negative 2e power of 2x plus 1. Then we need to differentiate the dy per dx bracket negative tan bracket 4y. So we also need to use chain rules and the answer we get negative 4 secant square bracket 4y times dy per dx. So the second step is we need to combine all terms. So it will get y per x plus ln bracket 3x times dy per dx minus 2e power of 2x plus 1 minus 4 secant square bracket 4y times dy per dx equal to 0. Third step is we need to separate the term with dy per dx to one side. So we need to move the y per x and negative 2e power of 2x plus 1 to the right side. So it will get ln bracket 3x times dy per dx minus 4 secant square bracket 4y times dy per dx equal to 2e power of 2x plus 1 minus y per x. So we need to factor out the dy per dx. So dy per dx times ln bracket 3x minus 4 secant square bracket 4y equals to 2e power of 2x plus 1 minus y per x. So the final answer we get dy per dx equals to 2e power of 2x plus 1 minus y per x divided by ln bracket 3x minus 4 secant square bracket 4y.
Question 4. Use linear approximation to estimate the value of 4 square root of 80.99 minus 2 over square root of 80.99 correct to 3 decimal places. Okay, first step is we transfer the value into x. So x is equal to 80.99. 80.99 comes from the questions and the x naught becomes 81. Why it becomes 81? Because 80.99, which we can round up to the closest number, it will become 81. So the x naught becomes 81. Then now we can transfer it to the formula to x naught plus square root of x equals to x. The x naught will become 81 plus square root of x equals to x, which is 80.99. So now we will find the value. The 80.99 will minus with 81 and it will become negative 0.01. Next step is we need to find the function for fx. So fx is equals to 4 square root of x minus 2 over square root of x. So why it becomes x? X is actually the 80.99 from the questions, but we change it to x. And now from the square root, we need to change it to the power. So x to the power 1 over 4 minus 2 over x to the power of 1 over 2. After that, we will find the inverse function for fx. So fx is equal to x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. And how does the 2x to the power of negative 1 over 2 form? The 2x to the power of negative 1 over 2 form from the 2 over x to the power of 1 over 2. But instead, we bring the x to the upward and it will multiply with 2. So that's how the 2x to the power of negative 1 over 2 comes from. And then after that, the power we need to bring in front of the x. So it will become 1 over 4x to the power of negative 3 over 4. The negative 3 over 4 is actually from the 1 over 4 minus 1. 1 over 4 is n, and n in the formula must be minus with 1. So 1 over 4 minus 1 is negative 3 over 4. So, and same goes to the x to the power of negative 3 over 2. The negative 3 over 2 comes from the negative 1 over 2 minus 1. So, where does the 2 in front of the x go? Like I said, the power negative 1 over 2 must bring in front and multiply with 2. So when the negative 1 over 2 multiply with 2, it will become negative 1. But in front of x, we don't write 1, so we just left it with negative x to the power of negative 3 over 2. So now finally we can move on to the next step, which we can use the linear approximation formula. So fx, f in the bracket of 80.99 equals to f in the bracket of 81 plus fx inverse in the bracket of 81 times with the square root of x, and we substitute the function, but the x will replace it with 81. So so in the bracket, 4 square root of 81 minus 2 over square root of 81 plus the 1 over 4 in the square root in bracket of 81 into square root of negative 3 over 4 minus 81 to the square root of negative 3 over 2 times with the negative 0.01. And also to mention that the 1 over 4 is actually comes from the fx inverse function. So all of that we need to substitute it, but the x we need to change it with 81. And then after all, when we simplify all of the numbers together, then the final answer is 2.778, which is in 3 decimal places. That's all. In conclusion, we have learned different techniques of differentiation that help us to understand how functions behave. We discussed how to find derivatives for trigo, exponential, and logarithmic functions in this assessment. The chain rule helps us to differentiate more complex functions, while implicit differentiation allows us to work with equations that are not solved with one variable. Finally, the linear approximations and differentials helps to estimate values and analyze functions closely. Understanding this concept is important for solving various mathematical problems effectively.